Alright, so in this video we are going to continue our discussion about exploratory data analysis. In the last video we talked about univariate data analysis when it comes to EDA, or exploratory data analysis. And now within EDA we're going to talk about multivariate data analysis, meaning multiple variate variable, multiple variable data analysis. And what this means is that we're basically looking at relationships between multiple variables. And the three broad classes, or the three broad applications of this, of multivariate analysis, so you're going to be looking at relationships between categorical variables and continuous variables, between categorical and continuous and continuous. Because if you remember in our other discussion, let's go up here, there are really two types of data that we're working with. It's usually discrete or categorical, which they're kind of used interchangeably sometimes, and continuous. And an example of that is education. Within this data set that we're using, the bike buyers data set, education must fall into one of these categories. You can't have half of these you can't have a half of a category or anything. It has to be one of those values. And then continuous, an example of that is income. It doesn't really have to be a specific value, and it's very subjective, and it's on a broad scale of what it could be. So those are the two basic types of data, and we're going to be examining the relationships between each of those comparatively. So we're not trying to answer the why questions right now. We just want to continue to describe the data by answering the what questions. What does this data contain? What are these relationships? And in order to do that, we're going to be using a lot of different functions that will print out stuff here in the console, but we also want to visualize things. So we're going to be using some scatter plots, density plots, box plots, just different things that we can compare these relationships. So with that being said, let's go ahead and jump into our first analysis, categorical and continuous. And by the way, this bike buyers data set, I'll try and provide it within the description of the video. I have it right up here at the top of my file. I'm going to go ahead and read it in. And then just from the last video, we ran this function as well to drop the ID column, because we don't want the ID column. It has no meaning in the analysis that we're doing. So if we look at categorical and continuous, and let's take a look at education and income. We want to know what kind of relationship there is between education and income. Pretty important insight that we can gain here. We're going to be using the by function, and so it's part of the base function, base package, and that's usually just included within R. And basically, it's going to apply a function to a data frame split by factors. So what it wants the data that you're curious about, and then indices. Let's look at indices, a factor or a list of factors. So here we are. We have income. We're curious about how income is affected by education. And this is the list of factors, these indices right here. And then lastly, a function to be applied to a subset of data. So we're calling summary on it. And this is exactly like we've used before, this summary function. So let's call it and see what it brings back. Alright, useful information, I think so. So right here it splits up each category of education that we have in this data set. We have bachelor's, graduate degree, high school, partial college, partial high school, and it gives the spread of each one of those things, each one of these levels of education. So this is the income for bachelor's. They have an average income of $62,000. Graduate degree, average of 66,000, high school 46, partial college 54. So it's very useful, and We can easily see it right away. Now if you want to drill down, if you don't want all these numbers, you can just call like this right here, call the mean. You want to pull back the average, and it'll just pull back that single value. And same with median, or the middle of the data. It'll pull that back and provide you valuable insight as well. And so if these two are different, the mean and the median, we know that the data is skewed either to the left or to the right. So now let's look at a box plot to look at the relationship between education and income, because this is helpful in everything down here, especially this right here. This is helpful, but we love visualizing it because our brains can digest it better. So we're going to use Boxplot. I'm going to run this and then we'll walk through what we're doing here. Alright, so this is a pretty useful graph here, pretty useful Boxplot. I chose to highlight the graduate degree for no particular reason, just showing that you can kind of customize your visualizations. And you'll notice some of these labels aren't appearing. Which means you need to increase the size of this window a little bit. But right off the bat, we can see that this spread, how the spreads differ for each education level. We can see that there are outliers up here. These dots up here are outliers. Anything within this line and this line, those are within the distribution of standard deviations. I believe it's 3 standard deviations from right here, from the median. So knowing this, we can say, okay, there are some outliers in every single category, and we can kind of see where each of these fall, each of these averages. I used median earlier, I meant to say the mean. We can see where each of these means fall. So let's go ahead and look at the function that allowed us to create this. It's kind of a long function, so I'm just going to pull this all the way over here. And now it's itty bitty. So we called Boxplot, right? And actually, I changed my mind. Let's pull up the documentation. Produce box and whisker plots for the given group values. So it's kind of interesting. It's asking for a formula, and it gives this funny little explanation here, such as y squiggly line GRP. And if you continue to read, it'll tell you what it's talking about, where y is a numeric vector of data values to be split into groups. So right here, here's income. It's a numeric vector of data values that we want split into groups according to the group variable. So group, usually a factor. So we have to use this little squiggly, and if you're not familiar with where to type this, it's usually right next to the 1 on your keyboard, just to the left. That's where it is on a Mac, and you usually press shift that button, whatever it's called, and then you pass it the factor or the group. In this case, it's education. Now I used some of these other arguments that aren't necessary, but I wanted to use them just to kind of emphasize the points I was looking at. So Knotch, if we look at Knotch, a line is drawn on each side of the boxes if the notches on 2 plots do not overlap. This is strong evidence that their 2 medians differ. So what that means, if we look at this, the notches, this notch right here and this notch right here are different. So we know that there's some discrepancy, there's some big differences between the data. Well, just for fun, let's go ahead and look at what notch false is. So it doesn't pull in the box right here. And really it's just a visual effect. I tend to like it just to emphasize that median value right there. So another one that I used, another argument that I used is call. Now if we look down here, we got to find call. Here it is, call. If it's null, it'll be, okay, so it's colors. We learned the colors. By default, they're in the background color. So I just basically put together a character vector right here that specified what colors I wanted. And so I said gray, gold, gray, 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 gray. So I wanted to emphasize this one right here. If I wanted to, I could change that. I could change that to green, and suddenly it changes which one is emphasized. And then lastly, we used main. We've seen this before. Oops, sorry. This is just giving a title to your graph, just to make it a little bit more descriptive. And really, you should never make a graph with no title. If you're planning on sharing it with anybody, really, it's a disaster if you don't use a title. So make sure to use a title. Alright, so that's a box plot. You can see it's pretty helpful. I'm going to go ahead and change this back to gray and gold. That's what I like. So now let's look at a density plot and see what comes up with there. So we're going to use the library SM. Oh, let's include it first. So library SM, let's use question mark, SM package summary information. So we're going to be using some functions from here. It has a list of a bunch of the functions in the package right here. So the one we're going to be using is sm.density.compare. Now let's take a look at what that brings back, and then we'll look at the documentation. So right away, it has some pretty interesting looking bell curves, right? But we can look at what we passed in, income and education. So we can kind of assume that each one of these represents a different level of education. And so we have an individual bell curve for each one. So if we look at the documentation, this function allows a set of univariate density estimates to be compared. What it wants is x, a vector of data, which we've provided, it's income, and group, a vector of group labels, kind of like what we did up here with the by function. It asked for a group that was a collection of factors. It wants a similar thing here, to where we have a continuous variable, we have categorical, or like a group of factors, and that'll allow us to make something pretty like that. So I know I just told you should never make a graph without a title. I didn't add one here, so let's go ahead and add one. And I'm actually just going to use this same title because it applies here. Oh, maybe that's not how you make a title with this one. Okay, well, you make a title somehow, but obviously that's not the way to do it. So at least I labeled the x-axis, and maybe that's why I didn't do a title, because when I did this before I found out that I couldn't add one easily, so I just moved on. But yeah, I labeled the axis right here, and this density is, you know, the density of the number of people that fall in that category. So one thing we want to notice about this is that we don't know which education level we're talking about, right? So we want to be able to have a key, something up here to say, hey, this pink dotted line is probably partial high school. That's probably what it is, knowing that the median for that was way lower than the other ones. So in order to do that, I'm not going to jump into too many of the details here. If you want to learn more about it, then feel free to just Google creating a legend and a graph for R. So what you have to do, you have to put together this legend by calling these, putting it into a factor and giving them labels, just like this. So if we call that, now we now have education legend down here. It's just kind of an abstract object right now. We're not using it anywhere. And now we're going to call these two things call fill and legend. Call fill legend. So if you notice, my cursor has changed to a crosshairs, and what that means is that I can now place something on here. So I just clicked and I added it on there, and now we can see which curve belongs to which educational category. So it's very helpful. So these two functions right here pretty much take care of assigning these colors to what they need to be. That's part of what you see here. The fill equals call fill. That's what we did up here, and we're determining the levels. The locator is what turns it into a crosshair, so I can click here and add it. So very, very helpful. And again, you can continue to research that if you'd like, but we are focusing on exploratory data analysis and not so much on creating pretty visualizations. So let's continue and look at categorical and categorical comparisons. So an example of that in this data set would be whether or not they purchased a bike right here, and education. So let's look at education just like we did for this last one over here. We're going to compare those two. We want to see, what kind of relationship there is between people's education and whether or not they bought a bike. So we're going to use something called XTabs, which is short for crosstabs, cross-tabulation. Creates a contingency table from cross-classifying factors. So this is kind of a funny one because it's asking for a formula, and we're not going to use a specific formula right now, and so I'm just going to kind of leave that side of the function blank, and we're just going to immediately put this squiggly sign, and then we go ahead and look and we say formula object with cross-classifying variables separated by a plus. So we want to cross-classify education and purchase bike. And what's different about crosstabs function is that usually you would give it the data set first. It's mostly how most functions work. The first parameter is the data. In this one, the data is after this first function. So you give it the formula and the two variables that you want to cross-classify, and then you give it the data. So I gave it bike buyers, and then I didn't have to say bike buyers education here. It just knows that you're referring to bike buyers. So if we use crosstabs here, right away we see there's some helpful information here. I have a column of no and a column of yes, and the education level of each of the observations. So this is helpful. We can eyeball it and kind of sort through. It looks like the most bought with those with a bachelor's degree. But let's visualize it. And so basically we're just going to take this and I copy and pasted it right here. And then I gave my graph a title, bike buyers and education level. So, and then we're going to call plot. And if you don't remember, plot is basically the generic function for R, and it does its best guess about what kind of graph you want. So let's see what it brings up. This is a pretty helpful graph that we have here. We have purchase bike on the y-axis and education on the x, or like the upper x axis. So it splits it right here, and visually it's helpful. If you want to dive deeper into the numbers, then you're going to have to run some other things. But right away we can see that most partial high school, look how many said no, they did not buy a bike at all. And the yes, only a tiny fraction of them. But the biggest majority here is bachelor's, and also the width. If you see the width, we have a lot more bachelor's degrees within this data set than partial high school or graduate degree. So that gives us good insight right away. Now let's look at who bought a bike versus their occupation. So we're going to copy kind of the same way we did it up here, but we're just going to change this occupation right here, and we're going to say cross-classify that with the plus sign against purchased bike. So let's run that. So here we have all of the factors or the categories of occupation within this data set. We can kind of look through and say, okay, professional, that seemed to be the most heavily used, or heavily yeses. So, and let's visualize that again. All right. So here we have, that's just kind of surprising that, we have so many professionals in here, and they are the majority of the yeses within this data set. So let's get into the details a little bit more, and this gets a little bit more, you have to know your statistics a little bit more for this next part. So we're going to be calling the library gmodels, and we're going to be using a function called CrossTable. And what this does, kind of like xtabs, it'll make a contingency table, but CrossTable just says cross tabulation implementation. It can bring back a chi-squared, and that's useful to know kind of the predictive power, or the levels of significance, I should say, for categorical variables against each other. So let's go ahead and run this really quick and see what's going on. And you can see I provided it with an x value, like I did here, and a y value. You have to make sure the y is the dependent variable here. So we're looking for purchase bike. And if we don't have it, if we have the purchase bike over in the x area, then that means that we're trying to use purchase bike to predict their education. And we don't necessarily want that. And this chi-squared, we want the chi-squared to come back, because that is our level of significance for categorical variables. And then this prop t equals false. That's just a certain part of the data that I said I don't want that to come back. I don't want to use that right now. So let's go ahead and run that. All right, so this has a lot of numbers. It may be intimidating at first, but it's given you cell contents. This is your map. This is your guide to understanding this table right here. So n is the first row, and that just means basically a count, the number of variables of that type there. And if we go right here, we can see bachelor's 137, 169. These are the number of observations within this data set that pertain to no or to yes. And then the row total, there's a total of 306 bachelor's degrees within this data set. We're going to look at chi-squared contribution. Now this chi-squared contribution, sometimes people refer to it as chi-squared. So depending on who you ask, I say chi-squared just because it looks like chi-squared. So right here, it's this second row within each major row of each category. And this is just the contribution to the overall chi-squared right down here. And if we look at the next one, so this is going to be the percentage of the row total. So if we look right here, 44.8% said no, they didn't get a bike, and 55.2% did get a bike. And the bachelor's degrees makes up a total of 30.6%. And that happens to correlate with the 306 because we have exactly 1,000 observations. So that breaks it down really easily for us. So that is a quick introduction to the cross tabs right here. And really what we want to focus on is this p-value. There's a lot of other things that you can kind of discern from using this. But if you look at this p-value right here, if you remember from your statistics class, maybe Stats 101, a very basic concept is that the p-value, if it's greater than 0.05, it means that this variable is not significant. So if we look right here, this is 4.312506, but minus 0.5. So we would take that decimal 1, 2, 3, 4, 5. So it's definitely not greater than 0.05, which means the education is significant when it comes to whether or not somebody would purchase a bike. And that's pretty valuable as we prepare to maybe do some predictive modeling to keep track of saying, okay, I know education has a big influence on it, so let's make sure to test that later as we predict things. So now just do a little mini challenge. I want you to explore the relationship between purchased bike and another categorical variable of your choice. Maybe commute distance, there's a couple other ones that you could choose, number of children or whether or not they're a homeowner, and just explore those two categorical relationships just like we did here. So I'll pause the video, or you pause the video and check that out. Alright, so hopefully you had a good experience exploring a little bit more of the relationships between different categorical variables, specifically purchased bike and another categorical variable. So let's move on to the last section. If you remember up here, towards the beginning of the video, we said we'd be going over 3 different types of relationships. So we've gone over 1 categorical and 1 continuous. We've gone over 2 categorical, and now we're going to go over 2 continuous. And this will be fairly brief compared to the other ones. Now, the problem with this and this data set is that there may not be necessarily good comparisons. What we could do, we want to look at 2 continuous variables, and something we could do is look at age and income and see that relationship. And we'd use a function called scatter.smooth, and that's going to create a scatter plot of each of these. And so as you can see, the income, this line right here is kind of the line of best fit. There's a little bit of a trend as age rises, so does income, and it kind of peaks right about here, and then about 55, 60, right around the age of retirement. This is maybe what you would expect to see. So that's a helpful visualization, just using a basic scatter plot to compare 2 continuous variables. So let's just look at the documentation real quick. So again, it wants an x and a y. That's the most basic. That's the most basic thing that you can supply it with, is an x and a y. And let's make sure to add a title to it. Plot income to age relationship. So there it is, income to age relationship. So very helpful, and if you can go in and you can change the labels for the x-axis and the y-axis so that it doesn't just have the column name listed here. You can just make it say age or income. So it's pretty straightforward. Now let's just use a different data set real quick to show this example again. I'm going to call library data sets. So R has a bunch of data sets already built into it if you want access to those. And one of those is MT cars. So I am going to save that into a variable called cars, and I'm going to call scatter.smooth, and there's a variable called miles per gallon and horsepower within this data set. So let's go ahead and look at the relationship there. So this is another interesting result. As the miles per gallon goes higher, the number of horsepower, right? I put the number of horses, it goes down as well. So there's a negative correlation here, not necessarily meaning that there is no correlation, but it has a negative trend here. So the more horsepower, the less miles per gallon. So again, continuous and continuous, it's a very helpful comparison. Hopefully this video helped along your path to learning EDA or exploratory data analysis. Thanks for watching.